Hi, and welcome back. Today we're going to cover two topics. We're going to talk about for loops, and we're also going to talk about conditional outputs for loop terminals. So we're going to go ahead and create a new VI. So we're going to create a for loop, a simple for loop structure that's going to iterate, let's say, 10 times. And so, for example, if we wanted to feed in an array of values and check which ones of those were greater than 10, for example, right? We might do something like this where we do a comparison. Is there a numeric comparison? No, comparison is in here. It's greater than. So we wire our array and we, let's say, check is this greater than 10? And then we might also want to then build an array of all the elements that are greater than 10. So let's wire that like that. Let's replace this with a shift register. And then let's say that, let's actually delete this. Let's just keep this simple. Let's say that if the array element is greater than 10, we wire it to this case structure. And we say, let's build an array. So we take, on the first iteration, it'll be an empty array, but afterwards, whenever you encounter an error, a condition that meets this condition, so the array element that you're feeding in is going to be greater than 10, it will build your array by adding. And then here we can see conditional array. So we can just expand that. Let's make this our empty array. So we've just initialized an empty array here, and then this is our test array. So let's fill this with some values. And let's say 7, 8, 9, 10. Let's say this is 11. So that's 1. Let's make this a little bit bigger. Let's make this 11. Let's make this 65. Let's make this 4, 75. And so this will just give us a quick example. Now you can see we also have to wire the false case. So the false case is where value less than 10. So, and then this is when the value is more than 10. More than 10. Now let's line this up a little bit. We're not going to do too much cleaning up because you'll see that we're going to get rid of this entirely in a second and use much simpler code. But generally speaking, you feed in an array of test values. If it's greater than 10, you add to this empty array that will be filled with those values. And then once you run this code, you'll be able to see which values are greater than 10. So if we expand this, we run this, we can see all the values returned are the values out of this test array that are bigger than 10. But this is more logic, more code, and in a simple case where you're just checking something like this, you may not want to have to build. And also, in the cases of building, this is actually slower than the next step that we're going to demonstrate. This is actually a slower way of creating an array. So you might ask then, how are we going to build an array of elements that are greater than 10? So what we're going to do is we're going to delete all of this logic because we don't need it. We have almost everything we need right now, right here. So we're going to use LabVIEW's auto indexing feature. So in this case, you'll see right now we can shrink this drastically in terms of complexity. And you can see right now if we release this as is, if we don't do any additional checks, we're going to get our whole array back. So that's not what we want. What we want to do is we take this input, which is all of the elements, it just gets passed. We say right click and we say tunnel mode and we say conditional. So what this will allow us to do is take the Boolean output that we have from here. So we already performed this check and we just simply connect to that conditional terminal now. And when we run this, you'll see in a second here that all of your logic will be as before. So 11, 67, and 75. Now, what you do inside of this loop really doesn't matter. You could be comparing strings. You could be doing a number of checks. This could be more complicated. This could be a cluster full of sub-elements, and you're doing complicated checks with regex, for example, or some reads or anything of the sort. But really, the main principle remains true, is that you can auto build using the the indexing feature, and then you can also select when to index that, so when to add the next element to that array. And in this case, we're just doing a simple check. And so that leads us to kind of the next portion of this tutorial. So for loops in general have a structure that's fairly similar to while loops, but they have a terminating condition, which is the number of iterations. A while loop has a terminating condition that you have to feed in a true or false to actually stop the looping. So in this case, we're going to go over a couple of these. So the n here is how many iterations that you want. So if you leave this unwired, this will not execute, and you'll need to provide it another way of knowing how many times to execute. So in this case, let's go ahead and say we have an array of, again, numbers. In this particular case, it will take one of these numbers as the number of iterations. But because this is 0, because there's zero elements, it actually, you'll see, will not execute. So we're going to wire this iteration counter. So this is the second element of it. It just tells you what iteration you're performing. So we can see right now, nothing will happen because it'll take the smaller of these two, which is also why when you're doing for loops or any sort of loop and you're using the auto indexing, you may want to make sure that you don't, for example, have two arrays being auto indexed, because if one is, for example, size 1 and one is size 2, and you're going to expect the output to be, for example, the addition of those two, then you're going to be surprised by the result, and the result will be an array of size 1, as you'll see, because between these three iteration count controls, so how many times this for loop will iterate, the smallest is this array of size 1, which means that the whole for loop will be dictated by this size. So that's actually a very, very common mistake that a lot of people make in their code, is that they have multiple auto-indexed inputs. So one way you can get around this is by disabling indexing and manually indexing this array, such as this, and then letting, for example, and not wiring the 10, then will be dictated by this size. And then you will know that because we're expecting that we're dictating by this size. There's multiple ways to do this. This is just one method. Or, for example, you could wire the 10 and then do the same index for both. But we're going to leave it at that. There's many different ways that you can do this. So we're going to right click the for loop and show you kind of the third element that you can do. You can do a conditional terminal. So the same way that you can stop a while loop, you can also stop a for loop. So here, if we say, if we create a control, actually let's make a condition, because this is only going to execute a couple times. So let's just do a comparison. So let's say if this is equal to 4, and then let's make the second element 2, let's make the third 4, 3, 4, and then let's say this is 5 and 5, just so we don't have it. So 1 plus 2 is 3, 2 plus 2 is 4, 3 plus 5 is 8. So really we should stop on the second iteration, which will be the first, which will be number 1 here. And so let's just wire that. So it should stop on the second iteration, but I is equal to 1 because it starts at 0. So again, you'll see that it stops here, even though we have more elements. So that's just a quick way. And then also, if you left click on this, you can change. So instead of stop on this condition, it will loop until that condition is false. So continue if true, rather. So stop if true is this red one. So if this is true, then it will stop, or you can change it so that you do something until the condition is false. So it's just a way to negate. For example, it's an easy way to negate. So we're going to get rid of that for now because we don't want the conditional. And then the last element is that you can configure parallelism. So this is more of a complicated logic. We're going to avoid this for the time being because it's a very advanced concept. If you want to read up on it, select help, or if you want me to make another video on this, then just write in the comments below and we can go over that particularly. And we're going to go over the output of a for loop as well very quickly. So as you can see here, if you just auto wire something, so for example, even just this constant, if you wire it, it will automatically select indexing, and it will build an array of size however many iterations occurred. And that could be an empty element, it could be whatever it might be, but it's going to be dictated by the size that you're running here, which is in this case, which is 4. But because we stop, it might not get there. So there's other methods that you can do. If you right click, you'll see a couple of them. So you see last value, and last value will take literally the last value that is in that is passed to it, so passed to that terminal. So let's select that. So in this case, the last value that we should see is 5 plus 4, which should be 9. And this is obviously not an array element. This is a single. So this won't be an array of 1. This will just be one value, which is an important distinction. So you'll see that the numeric 2, which is our output here. So this is last value. This is our indexed array. And then we also have one more option known as, and all of these can be, all three of these can be conditional. So that's something important to remember. You can make a last value that only gets updated. For example, so say you run 1,000 iterations of your for loop, but you want to keep the last value that meets a certain condition. You could theoretically wire a conditional loop, and then just loop over the whole case, or you could say last value without this conditional and just simply stop on your condition. So the last one we'll talk about is concatenating. Now for concatenating, it's an important distinction to make, so let's clean up this wire, is that you can only concatenate arrays. So what that means is that if you have, for example, in this example, if we are outputting an array, so instead of a single point that we had previously, much like this, where you index a single point and you build an array, because you already have an array here, what you're actually outputting is an array of arrays. So you have a 2D array. So I've already configured my indicator now to be a 2D array, as you can see, but you might not want that. You might want to just add your new array or your second array to the end of your previous one. So how you can do that is you just click concatenating, and as you can see, obviously with a scalar point it doesn't work, but with an array element this will work, and you'll have an array that is a 1D array instead of a 2D array like you see. So indexed array, and so this would be size 2, and this will be a 1D array. So that's a very quick example, but you can see here that the array of 1D remains a 1D array, but here you have a 2D array that's being built by your auto indexing. So if you have something where you need to add your new array in each for loop iteration to the end of the existing one, concatenating is the way that you would do that. And now these are a lot of topics coming at you at the same time, so please feel free to create a new VI, try some of these ideas out, loop and iterate while you can. Try these ideas out for yourselves and then put them into your code with proper logic, with proper commenting and documentation. And on that, I'll leave you guys, but if you have any comments or questions, please leave that in the comment section below.